Hello and welcome to the section of the MATLAB tutor. In the last section we learned how to solve algebraic equations, the most common types of equations that you're probably going to come across. And we use the roots command to do that. In this section we're going to tackle something equally common, and that is how do you solve a system of equations, a system of linear algebraic equations. And I really can't stress enough to you how common this is. You use it when you're solving circuits, electric circuits, you use it in mechanics, you use it in almost any branch of science and engineering, because lots and lots of physical things end up boiling down to systems of linear equations. So for instance, what I mean by this is, what if you wanted to solve this system of equations? X plus 2y is equal to 4, and 3x plus 4y is equal to 5. By hand, you could do lots of things. You could, substitute in and solve the variables. You could graph these guys and figure out where they intersect. You could do addition techniques. You can do lots of different things to actually solve this. In MATLAB, what we need to do is provide the equations to it in the form that it knows how to work with. And fundamentally, MATLAB is a matrix animal, like I've always said, really. So what we need to do is we're really going to use matrix methods to solve this guy. Now, if you remember back to your matrix algebra, and by the way, if you've forgotten all this stuff, you can go grab one of my matrix algebra tutorials and relearn it all. But basically, the way you represent this as a matrix is you have what's on the left-hand side of the equal sign, you put in a matrix. So these coefficients, the 1 in front of the x, the 2 that's in front of the y, the 3 and the 4, you put that in a matrix representing the left-hand side of the equation. And then you put the 4 and the 5, what's on the right-hand side of the equal sign, in a separate matrix. So basically you have two matrices. The left-hand side we're going to call the A matrix, and the right-hand side we're going to call the B matrix. And so what really happens here is to actually solve for x and y, what you're going to do is you're going to take the inverse of matrix A on the left-hand side and multiply it by matrix B. And that basically isolates x and y. If the details of why that works is fuzzy to you, then go grab one of my tutorials on linear algebra or matrix algebra and it'll all become clear. But the bottom line is that's what you're doing. You're taking the inverse of the left-hand side as a matrix, multiplying it times the right. So let's go ahead and first define the left-hand side of this equation. So the matrix A, we're going to use capital A. You can use any variable that you want. What we have is x plus 2y. So to represent that, it would be 1 space 2. That's the first row of that matrix representing the top equation. Then we put a semicolon. That tells MATLAB, okay, the next line of the matrix is what's going to be as follows, 3x plus 4y. So we put 3 space 4. So that is the second row. So when I hit enter, I've assigned this 2 by 2 matrix to variable A. Notice I have a 1, a 2, a 3, and a 4. And this all matches 1, 2, 3, 4 with what I have on the left-hand side of the equal sign. The right-hand side needs to be a column matrix with 4 and 5. So I'll say B is equal to 4 semicolon 5. The reason I put the semicolon there is because I want the B matrix to be a column matrix. Anytime you have a semicolon, it tells MATLAB to go to the next line when you're inputting matrices. We've already talked about that before. So we have the A matrix defined, which is the left-hand side of the equal sign in our system. And we have the B matrix defined, which is the right-hand side of our system. So ultimately, to find the answer, so I could say something like, solution. I could do it that way if I wanted to. I can set the solution equal to, it's going to be the inverse of matrix A times matrix B. This INV is a function in MATLAB. It takes the inverse of matrix A, it does a matrix operation to find that answer, and then it takes that inverse and it multiplies times matrix B, and that is going to be the solution. And the solution is a column matrix, -3 and +3.5. So it goes in the same order as your variables. Here you had x and y, so your answer is x and y. So the answer is x is equal to -3, y is equal to +3.5. So this is sort of one technique to do. You could do inverse parentheses matrix A multiply times B. There's many ways to write this. You could also say A raised to the -1 power times B. This accomplishes the same thing. I'm just showing you two different ways. You can send the matrix to the function that calculates its inverse, or you could just take the matrix and raise it to the -1 power, which is going to cause MATLAB to do exactly the same thing, and we get the same answer back in both cases. So whichever one you do is really up to you. Now also, there is a a shortcut way of doing that. If you take matrix A and do the backslash key, and then put matrix B immediately after, this backslash key is basically going to cause it to solve the system and give you the same answer. Let's go ahead and double check that first. We get the same answer. What this is doing is it's calculating it in a slightly different way. This is what's going on under the hood in MATLAB, but when you do it this way up here, you're calculating the inverse and you're multiplying. When you do it here, then MATLAB is using Gaussian elimination on the matrices themselves to calculate the answer. That doesn't really matter so much as far as a user is concerned, because ultimately you're getting the same answer. So here's 3 different ways to calculate the solutions of the system, and I'll give you a 4th way also. There is a function built into MATLAB called linsolve. That stands for linear solver, or linear system of equations solver. So you open up a parenthesis and you pass it matrix A. In fact, it's giving you help right here. Matrix A comma matrix B, like this. And what do you get? The exact same answers. So the bottom line is, when you're solving a system of linear equations in MATLAB, you have to put them into the matrices like we've discussed, and then there's really many ways to get the answer. You can pass the function A to the inverse function to calculate the inverse, then multiply times B. You can raise it to the -1 power, which gets its inverse, and then you multiply times B. You can take matrix A and do the backslash operator, which really calculates the answer with Gaussian elimination, but it's just solving the system either way, so you're getting the answers you want. Or you can pass the matrix A and B altogether to the function linsolve, which is actually calculating the solutions as well. Which method you use is completely up to you. There's no right answer to any of this stuff. So let me go ahead and clear the screen, and let's do one more quick example. A larger system. So here we have 3 variables, x, y, and z, and we have 3 equations. But the process is the same. We want to set up a matrix A that encompasses the left-hand side of the equal sign, and then we'll set up a matrix B that describes the right-hand side of the equal sign. So we have 2x minus y, so A is equal to 2x minus 1y. So 2 is this guy, and then we have -1, and then z is 3. Now we're going to put a semicolon because we're done with that equation. We're going to the next line. We have 4x, but look, we don't have any y's here. So because we don't have any y's, we have to put a 0 there. So we have 4 space 0, and then the last number in the second equation was a 5. So we'll put a 5 there and put a semicolon down. And then finally we have x plus y plus 2z. So 1, 1, 2. And that is our coefficient matrix. And you can see, let me just sort of show you, it lines up exactly with what we have. We have 2x minus y plus 3, 4x plus 0y plus 5z, 1x plus 1y plus 2z. So it all matches on the left-hand side. For the right-hand side, we have 5, 12, and -3. So we'll say b is equal to 5, 12, -3, and notice I had to put semicolons everywhere because we have to have the B matrix in terms of a column. We really want it to look just like it's written here. The B matrix is a column, the left-hand side matches perfectly. Now there's lots of different ways to do it. You could do linsolve A, comma B, and that'll get the answers. We have the 3 answers. X is equal to 10, y is -1.8, and z is -5.6. Okay, or we could do the other operator with the backslash, A backslash B, which is calculating the same answers. Or we could take the inverse of matrix A and multiply by matrix B, which is traditionally how you do it in linear algebra. You get the same answers. Or you could basically get the same result by raising the A matrix to -1 and then multiplying by matrix B, and you also get the same answers. So you get the same answers either way. You know, personally, I like this because it's pretty descriptive, and I love this if you're coding something, if you're writing a program, because this looks more like a programming language, and anybody should understand by looking at this. This is a linear solver, so it kind of makes sense to me. But any of them are totally valid. So make up some equations yourself and go ahead and play with MATLAB and just sort of see how it works. It's pretty simple to do, and I can't stress enough how important this is because you really use linear solvers like this to solve systems of simple equations, you know, constantly through all branches of science and engineering.